Alright, so I'm going to take some time to go through a few questions that you guys might have. At the end of the lesson today, you should be able to catch up on all the homework and you should be able to turn all of that in. I'll be stopping up there late to pick up homework from the bins there so I can take that and get it graded. So please have that done by the end of class today. So I have a few questions that I kind of tagged as just like basic review questions and a few questions that I had requests for. Okay, so I'm going to go through these in the video today and you guys are going to be following along on your homework. If you don't have them all and you turned it in already, then you should probably get that out of the bin. That way you can follow along with these and you can double check your work. If you do have it done, then I would like you to practice them again so that way you're not just sitting there watching me work through things. So please, if you have it done, get a piece of paper out and work through the questions again. Okay, because the best way to retain information is to practice it over and over. So starting out on page 386, this is 6-2 homework. Okay, there were a few word problems that were in the textbook. I just copied and pasted from the textbook here so you can see the answers if you wanted to check your answers, but I'm going to kind of work through them so you can see how to do them. Okay. So this person received $10,000 from her grandmother. Her parents invested all the money, and by 2027, the amount will have grown to $16,960. You need to write an exponential function that can be used to model the money y, and then write it in terms of x. So what that's is, it's just asking you to write an equation. Okay, sounds kind of fancy, but it's just asking you to write an equation. So if we kind of follow our exponential growth equation, so that's y equals a or p, your principal, whatever it is, plus 1 to times 1 plus r to the t. This is your general exponential growth equation. Okay, it's not compounded a specific amount of times. That's the one that involved the n. This is just your basic exponential growth equation. So you just plug stuff into there and solve for the variable that you have left, which will be the rate. Okay. So our final amount is $16,960. We started with $10,000, 1 plus my rate to t, and if we go from 2015 to 2027, that's 12 years. Okay, so the steps to solve here, you're going to divide by 10,000. I can't do anything with that exponent until this group is by itself. Okay, I'm going to divide by 10,000. And if you wanted to do that without a calculator, that's just going to move your decimal place 4 times. So that's 1.696 equals 1 plus r to the 12th. And then you're going to have to take the 12th root of each side here. When we take that 12th root of that function there, we end up getting 1 plus r is equal to 1.045, and so you'll just subtract the 1 and you would get your rate equals 0.045 or 4.5%. We didn't really need to go beyond this because you can just substitute this 1.045 in for the 1 plus r to get your equation right here. Okay, so in part B it says assume the amount of money continues to grow at the same rate, which is the 4.5%. What will be the balance in the account in 2037? So how many years from 2015 is 2037? That's 22 years. So you're going to use your equation here. Y equals 10,000 times 1.045 to the t, or x, which is 22, and that will end up getting you that $26,000 right there. Okay, next one is 31. So they're both word problems here. So studies show that an animal will defend a territory with an area in square yards that's directly proportional to the 1.31 power of the animal's weight in pounds. If a 45-pound beaver will defend 170 square yards, write an equation for the area A defended by a beaver weighing W pounds. So this is the equation that you should have, and I'll show you how we get that. Okay, so we're going to use this piece of information here. And then we're going to use this piece of information here, and then we're going to use this piece of information here. The variables that are given there are just kind of to make it look a little more fancy. But our general equation is y equals a times b to the x, if you remember that when we were writing our equations out, where we're going to be looking for that value in front. Okay, we know that the y is going to be the area that we can, or that the animal defends, and then the b is going to be the weight of the animal. Okay, so it says 1.31 power of the animal's weight. That's how we know b is going to be weight. Okay, so let's just go ahead and plug that stuff in. So we're defending 170 square yards. We don't know the coefficient there. We do know the weight is 45 pounds, and the power is 1.31. Okay, so now we can go ahead and put this in our calculator. You'll take 45 to the 1.31, divide both sides by that, and we'll get A equals 1.16. That's the number that goes in front of the W. And so then you just take that, plug it into your equation here, and it wants you write it like this. So area is equal to 1.16, which is my coefficient, times the weight of the animal to the 1.31 power. So then using that equation, we're going to get B. Okay, so it says ancient beavers were 11 feet long and weighed 430 pounds. That's the weight we're going to use. Okay, and we're going to figure out how much or how many yards or what the area that animal would be able to defend. So 430 is the weight to the 1.31. If you go ahead and put this information in your calculator, so 1.16 times 430 to the 1.31, you'll get 3,268 square yards. Okay, so that's 6.2. Jumping ahead. 6.4. So starting out the first few of these, just to kind of review how we do logarithms, they should be pretty straightforward if you paid attention well enough in class. For each of these, we're just evaluating logarithms. So there are a couple of different ways to do that. You can know that logarithms are going to give you an exponent. So like what exponent of 8 would give me 512? What exponent of 27 would give me a 3? What exponent of 1/8 would give me a 512? If you can't visualize that in your head, then you want to set these up like this. Okay, so set them equal to x, and then we're going to turn them into exponentials. Okay, so we do check mark, 8 to the x equals 512, and from there it's just trying to get those to be the same base. Okay, so 512 is actually an exponent of 8, so we can leave the 8 here, and this is going to be 8 to the third, right, because 8 times 8 is 64. 8 times 64 gets me to be a 512. So once we get the same base, those go away, we get an x equals 3. Okay, same kind of idea here. 27 to the x, we do our check mark method. 27 to the x is 3. So we're working to get these to be the same base. 27 is the power of 3, so that's our base we're going to use. So 27 is 3 to the third. Remember, we got that x hanging up there, so we got to write 3x. And that's 3 to the first. Okay, because that's our exponent there. We get rid of the base, set the equation up, and then solve for x. Divide by 3, we get x equals 1/3. Okay, and that makes sense because this is actually a cube root, right? So if I take the cube root of 27, I'll end up with a 3. So let's check the next one here. So same kind of deal, 1/8 to the x. Check mark it. And this one shouldn't be that difficult because we just did one up here above with 8. So we are probably going to be using an 8 since we have 1/8 and 512. But remember, how are we going to get 1/8 from an 8? Negative exponents. Okay, so 8 to the -1 gets me 1/8. But I have an x up there, so I'm just going to keep that up there. And then 512 is 8 to the third. So get rid of the bases. We have our equation, negative x equals 3, x equals 3. Okay? Because if we give this a negative exponent, remember what negative exponents do? They flip fractions, or they flip whole numbers into fractions, and then they take them to whatever exponent you have. So this would flip that to an 8, take it to the third power, and it would give you 512. Okay, let's look at a couple graphs. I know that these are probably the harder portions of that first lesson for logarithms, like how do we graph these things? Okay, well, you're going to have to remember that this has to be a power of this. This right here is going to have to be a power of that base. That's how they work. And that's how you know what to put in your XY chart. So either way, we're going to have to take an XY chart and use that. So let's kind of throw some powers of 1/5 off to the side. 1/5 to the something. So let's say 1/5 to the -2. What's that going to be? 1/5 to the -1. 1/5 to the negative. Nope, we're on 0 now. 1/5 to the 1. 1/5 to the second. What are these numbers going to be? What's -2? That's 25, right? So we know that our x is going to be a 25 here, and our y is going to be a -2. Right? So I'll show you here. If we did log base 1/5 of 25, we know that 1/5 to the -2 power is going to get us 25, so that log is going to evaluate to a -2. Okay, then our next one is going to be a 5, that's a -1. Next one is going to be a 1, that's an exponent of 0. Next one is going to be a 1/5, that's an exponent of 1. And the last one that we need is going to be a 1/25, and that's an exponent of 2. Okay. So I'll show you another way here that we can work through this. If you don't like, it's kind of harder for some people to visualize what those exponents are going to be. So the other way is actually turn it from a logarithm into an exponential and then plug in for the y. Okay? I did not show this in the video because I wanted to try a different method of doing it this year. Okay, but this is just another option for you to do it. So this is our logarithm, and we're going to change this to an exponential because it's going to make it easier to plug stuff in. So boom, boom, check mark from the base to the other side. We have 1/5 to the y equals x. Right? That's how we turn those into exponentials. We go from the base, check mark, to the other side, and then we now have this. Okay, so I've turned this into an exponential equation. I don't want to plug into the x because it's going to make it just as hard as I did it over here. I want to plug into the y. So if we think about values to plug into the y, you could do an xy chart like this. We go -2, -1, 0, 1, 2, and then you'll get your values here, which should be exactly like that, right? I do 1/5 to the -2 for my y, I get 25. Okay, so either way that you want to do that, it's up to you. So remember, we look with the x. If there's nothing with the x, then your asymptote is y equals 0. So it's the axis here. We're never going to cross the axis. We're going to approach it. So let's start at these values here because that's really close to my axis. 1/25, 2, 1/5, 1, 1, 0. Remember, that's the point that they all share, unless it's a transformation. 5, -1, we're here, and then 25, -2, we're kind of out here somewhere. So it's going to be like so. We kind of curve away from the axis here. And then my arrow right there. Okay, so that is our logarithmic graph of log base 1/5 of x. Let's try this one up here. Okay, so I'll do it first like I did it in class. Alright, so we want this x minus 4 to be powers of 5. So we want x minus 4, we want x minus 4 to be, so what's 5 to the -2? That's 1/25. Okay, we want x minus 4 to be 1/5. So let's say 1/5. We want x minus 4 to be, another power of 5 that people forget about is the 1, right? 5 to the 0 equals 1. We want x minus 4 to be a 5. Then we want x minus 4 to be 25. Okay, so we set these up here. So let's make our XY chart based on these values. So I'm going to add 4 here. I get 4 and 1/25, or that's going to be 101 over 25, right? Because if I do 4 plus 1/25, common denominators, this is going to be 100 over 25. So it's 101 over 25. Okay, over here, same kind of idea. This is going to be, so I add 4, so it's 4 1/5, or that's going to be 21/5. This one here is going to be a 5, this is going to be a 9, this is going to be a 29. And then we actually have to plug them in, okay? But we said that this one is going to give us a -2 power. So let's just say that log will turn into -2 minus 5, -7. We said this one's going to give us a -1 power. So that log turns to -1, you get -6. This one, we said that's going to give us 0 when you put that in there, right? We can check this one, it's a little bit easier. 5 minus 4 is 1, so what power of 5 would get us a 1? That log turns into a 0, 0 minus 5, -5. Then we said this would give us a 1 power, right? So 1 minus 5, -4. This will be a 2 power, so 2 minus 5, -3. Okay. So let's move that XY chart. Let's get rid of this stuff, and I'll show you the other way. And we'll move our XY chart over. Alright, so the other way. Change from a log to an exponential. You want this a y, not an f of x. And in order for you to exponentiate a log or turn it from a log to an exponential, you gotta have the thing by itself. So these are a little bit more complicated when we do it the other way. Okay, anytime you have more than just a log of a number, it's more complicated anyways. So move the 5 over, and then you got y plus 5 equals log base 5 of x minus 4, and now you can check mark it. Okay, that whole thing right there, that whole group there goes as the exponent for 5. So 5 to the y plus 5 equals x minus 4. And then move the 4 over. And then that's what we're going to graph now. Okay? And you can kind of see, if you remember graphing exponentials on 6-1, you want to plug in stuff here that makes it work out nice. Alright, so if I'm doing my XY chart, sorry it's kind of crooked, I'm plugging into the y. My middle number is what's going to make that a 0. So my middle number is -5. Hey, I got a -5 over there. And then I pick numbers around that. And then you plug into the y and work backwards. Okay? And you're going to see that you'll get the exact same numbers that I did there. Either way you want to do this, these are going to be a little bit complicated. Okay? So let's graph those numbers. Alright, and look back up here. We can find our asymptote there. Remember, it's always backwards, so your asymptote's at 4, not -4. So let's draw that dashed line at 4. Okay, and then graph our points. So this is like 4 and 1/25, and we're down at -7. So right about 3, 6, right about there. So that's right on the line pretty much. And then this one is going to be like 4 1/5, -6. And then we're at 5, -5, 9, -4. So 5, 6, 7, 8, 9, -4, and then it's going to kind of shoot off in outer space from there. So we're going up here, and then it starts to curve like so. Okay, these are harder. These log graphs are kind of difficult. Okay, but either way you want to do them, whichever works in your brain best. Okay, that's the way you're going to do them without a calculator, or I guess without using change of base formula, because you'd have to do change of base formula like 5 times if you did it that way. Okay, so that would be 6-4. Hopefully that kind of refreshed your memory of 6-4 and check your work again. Now we're on to 6-6, and we'll finish with 6-7. Okay, and remember, after these you're going to have a review assignment, which I will show you, point you in the right direction. Okay, starting off, these aren't too bad. You have to use properties of logarithms. Okay, remember, if we had our logarithms, we had log of x, y. If you're multiplying two things inside of a logarithm, you can split that up as two logarithms being added together. Okay, if I have two things being divided in a logarithm, such as this, log of x divided by y, this can be subtraction. Log of x minus log of y. And then the final one here is if I have an exponent with a logarithm or something inside of a logarithm, that can come out front. So it'd be 2 log x. And the base, whatever the base is, it's always going to stay the same in these. And when you're looking at these, you kind of think backwards from exponents, right? If I have, or you kind of think similar, I guess, not backwards. If I have x squared times x squared, what am I going to do with the exponents? I'm going to add them, okay? This would be x to the 2 plus 2. They work the same way. If I'm multiplying two things inside of a logarithm, I can split those two things and add them as two separate logs. Remember, if I had division of like bases with exponents, those are going to subtract, so 5 minus 4. So here, I'm dividing two variables. I can split them into two logarithms and subtract, okay? And then this would be compared to a power to a power. I have a log to a power, so I'm going to multiply the log by whatever that power is, okay? They're very similar to properties of exponents, okay? Because we know if we're multiplying exponents, we add the exponents. So if we're multiplying things inside of a log, we add the logs. Okay, so this right here is division, so we can split this up. This is my arrow, I'm just going to show what I'm splitting it up to. Log base 4 of 2 minus log base 4 of 3, and then we actually have values up above here to use for that, and then you can just throw those in there and then throw it in your calculator for some simple subtraction, and then whatever you get out of that, you'll get your answer. Okay, now this one here, we can do it a couple different ways. Alright, log base 4 of 4 minus log base 4 of 3. And now we can go even further here because there is no log base 4 of 4 up there. We can probably use this one if you wanted to. Log base 4 of 2 plus log base 4 of 2, because that's just 2 times 2, right? So that turns into this, log base 4 of 3. Okay, now I want you to recognize something here. This is 0.5 and that's 0.5. So 0.5 plus 0.5 is just 1. So a property that you may not have seen in the video yesterday, if you have the base match the number inside of the logarithm, it's a 1, right? So this is like 4 to what power gets me a 4? Well, that just turns into a 1. So there wasn't really much more. You didn't have to do this, but you could have. But this would be 1 minus log base 4 of 3, which is 0.7925. And whatever you get out of your calculator there, that'll be your answer, okay? So the next one's down here. Same kind of idea, all right, but you're supposed to use an 8 and a 9. And I'm going to show you this one. You cannot use an 8 and a 9 to get a 48, okay? However, we can use a 6 and an 8. Would that work? Well, let's look. Log base 6 of 6 plus log base 6 of 8. Remember, we're adding because we're multiplying these numbers inside of there. So what did I say this is going to be? Log base 6 of 6. If those match, that's just a 1. So we're going to have 1 plus 1.606. So, oops, not 602, 606. So 2.606. I can do that one in my head. Okay, this one should be pretty obvious. 81, 9 times 9. So this will separate to log base 7 of 9 plus log base 7 of 9. And you're just going to have that twice. Okay, another way you could have done this, log base 7 of 9 squared, right? So then I would use my other property where the square comes in front. So it would be 2 log base 7 of 9, which is 2 times that. Either way, they're going to do the same thing. Okay, now the next problems jump right into solving log equations. Okay, you're going to use properties of condensing logarithms here, so we're going to put them together. In order for you to solve log equations, you have to put them together so there's only one log on the left and one log on the right, okay? Or so there's just one log on either side. So like this one, there won't be a log over here, okay? And I think that's a 3. There's not going to be a log over here. So this is one where we're going to have to turn it into an exponential before we get to solve. Okay? You're going to want to practice some expansion and condensing of logarithms. Okay? Say I have something like this, and I need to separate that out. Okay? Well, you're going to have 3 different logarithms because we have 3 different things inside of the logarithm. All right? So the Khan Academy video that I sent to you, or the resources I sent to you guys, should be able to do that, but you're going to want to practice that stuff. Okay? So let's try to put this one together and solve it. So I have log base 2 of 4x plus log base 2 of 5 equals log base 2 of 40. So I need to condense these, and by condense I mean put them together. So if I am adding, what do I do with the stuff on the inside when I put them together? Okay, think backwards from exponentials. We're going to multiply them. So this will turn into log base 2 of 4x times 5, which is 20x. Okay, because this means multiply. And then over here, we got log base 2 of 40. And now a property of logs, if we have the same log on both sides, they just cancel out. Okay, just like if we have the same base on both sides, we can cancel them out and work with the exponents. Same thing with logs. So we have 20x equals 40. From there, it's a pretty straightforward problem. Divide both sides by 20, x equals 2. And you can plug that in, right? So here I would have an 8 if I plug that in. If I condense them, 8 times 5, 40. Okay, so the next one here, we're going to try to solve for n. So we have log base a, right? It kind of looks like a goofy 6 or a goofy n. Okay, that's an a down there. So condense on the left here. We can't do anything on the right because it's the only one over there. So subtraction, what does that mean? Okay, sometimes I say, what does subtraction mean in log language? That means divide. So I'm going to put them together. Log base a of 6n divided by, and I forgot to mention this one, where should this 3 go before I condense them? Okay, I can't do this yet until this 3 is gone. That's got to go up. Okay, numbers in front of logarithms turn into exponents. Okay, now I can put that underneath there, and I have this logarithm on the left and this logarithm on the right. So what can I do with the logs if I have the same thing? That's right, cancel them out. And then we have this equation left. And we're supposed to solve for n. Okay, that's what the textbook is asking us to do. So there's a couple steps here. How do I get the x cubed out of the bottom? Multiply both sides by x cubed. Alright, they're gone over here. I get 6n equals x to the 4th. Divide both sides by 6, and I got it. So I have n equals x to the 4th over 6. That is what I get when I solve for n. Okay, let's try this one down here. So again, we're solving for whatever variable we see here. So that's an a, I think again, it's an a squared. I was kind of being fast when I wrote these in there. So let's condense on the left. I see a plus. That tells me I need to put them together by multiplying. So log base 3 of, so I multiply this into the group. 3a squared plus 9. Okay, you're going to have to FOIL that. If I'm multiplying this times that group, I FOIL it. Or I distribute that, excuse me. And then I got a 3 there. Okay, so now we might be stuck here. What do I do? I have a log on one side and a 3 on the other. I just can't cancel that and go from there. So when you run into something like this, where there's just a log on one side, we're going to have to use our check mark. Okay, check mark, boom, boom. We go 3 to the third. Okay, you'll see how this works. It works pretty slick. Now I exponentiated that. I turned it into an exponential. So my check mark got me from a log to exponents. And now I can solve from there because the log is gone. So 3 cubed, that's 27. Couple steps to get us to solve for a here. Minus 9. Oops. Come on, computer. Oh my gosh. So we subtract 9 from both sides there, and we're going to get 18 equals 3a squared. Divide both sides by 3. We'll get a squared equals 6. And we'll have to square root both sides of those. We get a equals plus or minus the square root of 6. The square root of 6 doesn't work out nice, and we'll get 2 answers there. Okay? Now when you are solving log equations, okay, remember we can't have negatives inside of logarithms, but this one actually works okay because we're plugging it into a square. Okay, that's where it's going into. But if we have, remember I had this on the slide the other day, if I have log of x, x has got to be greater than 0, okay, because we can't have any negatives in there. Okay, and this also implies that x cannot be 0. You're not going to have an exponent that turns a number into a 0. So it can't be negative, it can't be 0. So make sure you're double checking that when you check your answers. Alright, almost there. So, this would be lesson 6-7, okay? And this was the one that you guys just had yesterday, trying to look at working through some of these equations, and there's a couple of these that are a little bit harder, alright? A formula that wasn't given to you on the video, it's called the change of base formula. It was in the textbook. Okay, if you have log base a of b, this might be, let's say, log base 2 of 7, right? So what power of 2 gets me to a 7? I don't know. Some people have the power to do that, or have the option to put the little number in there for logarithms. A lot of people don't. So you're going to have to use change of base formula. And even if you do have the option, you might have a little box there and a box there. You're going to have to show me that you know and understand the change of base formula. Okay? There's sections on the test that say, show me the work as if you did not have a calculator. Alright, so this one. So the way I evaluate this with change of base is when a logarithm doesn't work out nice, I can do log, I can use common logs. So I can do log of b over log of a. Okay, and remember when I say common logs, that's just log base 10. That's essentially just throwing it in your calculator, the log button in your calculator on the left. Okay, You can also use natural log if you wanted to, but we're not going to get into that until tomorrow. Okay. But this one, if I wanted to evaluate this in my calculator, I would just do log of 7 over log of 2. Throw both of those in my calculator. Okay, it's going to give me parentheses when I press the log button, so make sure you close those off. And that'll give you, you'll estimate to the third or fourth decimal place maybe, so you have a good estimate. And I'll do that right now so you can kind of see that. So log of 7 divided by log of 2, you get approximately 2.8073. Okay, so if I took 2 to the 2.8073 power, I would get about 7. Okay, this is a formula you want to have written down somewhere. I'm not going to give it to you. You have to know that. Okay, now we're going to use that to solve some of these equations. So this one, I have 5 to the x power equals 55. There's a couple of ways to solve this, but I'm going to show you the way that you should be most familiar with. Right? So remember, if I have an exponential and I'm turning it into a log, check mark it. But it's kind of backwards because we're working from exponentials to logs. You always start at the base, check mark to the other side, and that's the base of the log. Base of the exponent is the base of the log. Right? So that becomes a little 5. Log base 5 of 55 equals x. And now this is where you might have got stumped, because like, oh, I can't do that. Some people can do that in their calculator. Okay, so now this is where you're going to use change of base formula. So I would do log of 55 over log of 5. You put that in your calculator and you estimate it. And you get 2.4898, so 2.4899. That's what you get when you use change of base formula. Okay. And you're going to have to do that down here as well. So the numbers like 32, 33, 34, I think, you're just going to use change of base formula. So I can kind of jump to that here quick. This would just be log of 18 over log of 7. And it tells you to express the answer in form of common logs. That's just telling you to use change of base formula. So if you put that in your calculator and just estimate whatever you get as an answer. Okay? So let's work through these last 3. And I think this one here takes quite a bit of effort. So we can kind of go through that one when we get there. This one isn't as bad. Okay, so let's try this one. Same way as the one above. We got to do the check mark. So log of 2.9, log base 2.9 of 8.1 is equal to, I think that's an a, minus 4. Okay, start from the base, which is the 2.9, check mark it, boom, boom. Log base 2.9 of 8.1 is equal to the exponent. Remember, logs always equal the exponents. Okay, this is something you can just slap in your calculator using change of base, but I'm going to move the 4 over. Okay, so we'll have log base 2.9 of 8.1 plus, that should be 8.1, it kind of looks like 8 times 1, plus 4 equals a. So if I put this in my calculator with change of base, log of 8.1 over log of 2.9, whatever you get there, add 4 to it. Okay, so I'll do that here. So it's 1.965, we'll add 4 to that, so it's going to be 5.965. That's what we get for A. Almost there. So, same idea here. It's kind of a little bit harder to do this one because we have exponents with it, okay? But we're going to use properties of logarithm to kind of work through it. So let's check mark that. So log base 9 of 7 to the b, right, because we want this whole side inside the logarithm, is equal to b minus 1. Okay, so now we have to remember what we got to do with exponents with logs. That's got to go out front. Okay, so it's going to be b times log base 9 of 7 is equal to b minus 1. And now this is where it's kind of interesting. Remember that I can just throw this in my calculator and get a decimal. I did that over here, right? We did change of base formula. So that's going to be my advice to you, is just to kind of turn this into a decimal, and so the log actually goes away. It's just the actual number. Okay? So if I put this in my calculator off to the side here, it's going to be log of 7 over log of 9, right? Just change a base. Log of 7 divided by log of 9 is going to get us about 0.886. Okay, so let's just throw that in there. 0.886b is equal to b minus 1. We're going to subtract a b from both sides, move that over, so 0.886 minus 1, you'll get negative 0.114 is equal, or we got to get that b there, right, because we subtracted the b's there. Negative 0.114 is equal to negative 1. Divide both sides by negative 0.114, and we'll get b equals 8.74. And then you could put that in here if you wanted to, and you should get very close to the same answer on both sides. Okay? This one's a little bit different because I'm doing my check mark and I'm going to the other side that has an exponent there already. So it's going to kind of force you to use the check mark to exponentiate, and then it's going to make you use the law of logarithms there, or a log rule where you bring that out front. Okay? One more here. So we can't set these to the same base, and that's another thing I forgot to mention here. I know that I have to use logs because I can't set these to the same base. 9 and 7 don't have powers of each other, right? 2.9 and 8.1 probably don't have powers of each other. Okay, you can do 2.9 to something to keep trying, but I don't think that it has the power to get you to 8.1. Here, 2, there's no exponent for 2 that gets me to a 20, or no exponent of 20 that would be rewritten as a 2. So that's how you know you have to do logarithms, okay? So when we check mark this, boom, boom, this is always going to be pointing the same way compared to the x. So right now it's pointing at the x, so when I rewrite it, it's going to be pointing at the x, wherever that is. Okay, so that's my base, log base 2 of 20, and then the x is going to be over here, so we're pointing to the x like that. All right, pointing to the x here, pointing to the x here. And now I just go ahead and solve like normal. Change a base formula there, divide it by 4, you'll get x is less than something, less than or equal to, okay? Divide both sides by 4, divide both sides by 4. I'll write my change of base stuff over here. Log of 20 over log of 2 is approximately, you got to make sure you close those parentheses off when you do this, because if you don't close the parentheses off, you'll get a different answer. So that change of base formula gets me about 4.322. And we want to divide that by 4 according to our work here, right? Change of base gets me the 4.322, divide by 4. You get 1.08. So x has got to be less than or equal to about 1.08. And you can plug that in, and you'll always get the correct answer. Okay? So I hope this helped you work through a lot of the homework. I know I've been gone this week. I'm going to use this video in the future just for people if they need help. But I wanted to take some time to work through some homework questions, and you're going to want to use this for review. Okay? So your actual assignment, you have Khan Academy work to do. And I'll show you where that is. And then there's also a worksheet from 6.6 and 6.7. I'm going to have something that has a combination of those, okay? Or I'm going to see if I can find a worksheet that has a little bit of everything, okay? So don't quote me in the video. I got to find that still, okay? So let me show you a little bit of Khan Academy here. Search Khan Academy, and right there it pops up. And you actually should have an email from me, okay? And you might not be able to see it right now, but there should be a sign in or create account or something like that right there, and you've all been added to my classes, okay? So once we, and it looks like some of you might be joined already, okay? Okay. And so as soon as people join in class tomorrow, I'll make sure that I update these. But I've assigned the logarithm unit to you guys, okay? So you're going to have to work through intro to logs, constant E, and natural logs. So this will be good for tomorrow. We haven't done much with this yet. Properties of logs, and I want you to get through the quiz, okay? And we're going to try, if there's not enough time to do this in class, that's fine. We're going to try to work on these piece by piece. If you already know how to do a lot of this stuff, then you can kind of skip to the exercises and work through the exercises, and it should give you credit for that, okay? And it should just advance you to the next thing. As long as you do the exercises and you show that you've mastered the exercises, it'll let you move to the next deal, okay? So it's not like you have to sit there and watch the entire video or watch every single little thing or read the articles. You can work through the exercises and get from one thing to the next pretty quickly, okay? So that's your assignment. Let me know if you have questions. I'm feeling a little bit better, so I should be able to try to answer some questions as you need them. All right, so good luck. Thanks for watching, everybody.